Welcome to the video demonstration of OmniCant, a micro-cantilever-based sensor analysis platform that can be used for detection of gaseous phase analytes such as volatile organic compounds and headspace gases. OmniCant has been designed for analyzing the response of gaseous analytes to piezoresistive MEMS and NEMS sensors such as micro-cantilevers and conducting polymers. This system has been indigenously designed and developed by Nanosniff Technologies in association with the Indian Institute of Technology, Bombay. OmniCant is a tabletop equipment that can be installed in any laboratory, in research labs, colleges and universities, and does not require a clean room facility for conducting gas sensing experiments. The left side of the system shows the fluid flow path for the carrier and analyte gases. The system needs to be connected to a carrier gas cylinder, and it has an inbuilt mass flow controller to control the carrier gas flow precisely between 1 and 100 milliliters per minute. The cantilever cartridge is a microfabricated cantilever die which contains up to 4 cantilevers and is mounted on an SD card sized PCB for easy plug-and-play operation. The cantilever cartridge is housed in this cartridge holder called the flow cell, which is located in the center of the system. The cartridge can be easily inserted like an SD card, and the flow cell can be heated up to 90 degrees Celsius for binding reactions taking place at higher temperatures. This is the analyte vial chamber in which the target analyte is stored during the experiment. The analyte vial can also be heated up to 90 degrees Celsius for vaporizing the gases with lower vapor pressures. The headspace chamber for collecting the analyte vapors is made out of Teflon. The entire gas flow path is either made of Teflon or is Teflon coated to minimize the sensor response to impurities. The system houses automatic gas flow valves to direct the fluid flow with the touch of a button. The carrier gas can either go directly to the cantilever flow cell for purging and flushing the cantilever sensors, or it can flow through the headspace vial containing the gas vapors for sensing. In today's experiment, we shall study the affinity of acetone vapor molecules with a polymer called polyvinyl pyridine or PVP, which is coated on the surface of our cantilevers and is known to respond to aliphatic compounds such as IPA and acetone. We are using diluted acetone as our analyte, which is stored in the analyte vial and maintained at 40 degrees Celsius. Now to start the experiment, we shall press the on-off button twice. This feature has been incorporated to avoid accidental starting or stopping the experiment. The system starts with showing the initial resistance values at the time of calibration. It also shows the time and date of the last calibration run. The system then detects and shows the current resistance values of all the previously detected cantilevers. The experiment flow has been designed to prompt the researcher so that no critical step is missed at the time of experiment setup. The system first prompts the user to set the MFC flow rate for pre-experiment carrier gas flushing to ensure that the cantilever surfaces are clean and ready for interacting with the analytes. The flow rate can be set from 1 to 100 milliliters per minute using the up, down and enter keys. We shall set it to 20 milliliters per minute. After setting the flow rate, it expects the researcher to wait for the flow rate to stabilize. It then prompts the user to enter the pre-flush time, which by default is 10 minutes. The flushing starts instantly and the user has to then wait for the pre-flush time. As we see that the flushing has now completed, the system prompts the researcher to enter the MFC flow rate at which the gas will flow during the experiment. The system maintains this flow rate through the cantilever flow cell now. The system then prompts the user to enter the temperature of the analyte vial heater and subsequently of the flow cell temperature for performing this experiment. As soon as the system parameters are set, the recording of the cantilever data starts and it is displayed real-time on the on-screen LCD display. As we see that there were 4 live cantilever channels, there are 4 individual graphs of resistance versus time that can be seen on the screen. These graphs can be individually turned on and off on the screen using the channel buttons on the left side of the display. Turning off the channels only turns off the display. The recording of the cantilever data continues within the internal memory of the system. As we can see that the response of the cantilevers has stabilized with the nitrogen gas flow, which is the carrier gas for this experiment, we are now ready to expose the PVP coated cantilever to the acetone analyte vapors. We just have to press the annulate button on the left side of the fascia to start the annulate flow, which is automatically controlled by valves inside the system. The flashing of the on-off button indicates that the cantilever is now being exposed to the annulate vapors. As we can see on the system display, the cantilever has started responding to the acetone vapors and the resistance value has shot up as indicated by the sudden rise in the graph. We now turn off the annulate valve by pressing the carrier gas button. With the flow of only the carrier gas, the annulate molecules on the cantilever surface dissolve and get flushed off, regenerating the cantilever surface and releasing the stress. The same can be now seen with the fall in the graph indicating the cantilever resistance coming back to its original resistance value. After concluding the experiment, we can turn it off by pressing the on-off button twice. The summary of the entire experiment is shown on the display after the experiment has been stopped. The total response of each of the cantilevers can be viewed independently using the channel buttons on the left of the display. The system prompts the researcher to perform a post-flush of the cantilever flow cell after the experiment, which is similar to the pre-flush demonstrated earlier. Lots of such experiments can be done using OmniCant by varying the analyte concentration, temperatures, and flow rate to study the response of different types of coatings on cantilevers.